Welcome, everyone. It's so nice for you to be here. And thank you, Rob and David, for giving us this presentation. I've said this before, but things like this really help share knowledge around the community and um, are such a great insight into how other teams work. Because, as Jean's previously mentioned when we were just chatting before the presentation started, we don't all work in the same ways, and we can certainly all learn from each other. So that's exactly what this is about. So I don't want to do any talking for you. This is a presentation about the dress code project. And without further ado, um, Rob, kick us off.
All right, that's actually David kicking us off. So, David,
Oh,
Yeah, yes.
David, kick us off.
Yeah, no, well, yes, as Alex said, welcome and hello. And we're gonna Rob and myself are gonna be giving you basically a rundown on dress code and in particular the back end rewrite that the whole entire team has done. So I'm just gonna share my screen. Yeah. Let me know if you can't see, by the way.
didn't you want me to share the screen at the start?
Oh yeah, okay. So yeah, that you're
Tell
right.
me when you want the next
Yeah,
slide.
yeah. Okay. If you just yeah. Okay. So yeah, basically, I'm just going to give a quick overview of what dress code is as a charity, because it's not just a particular technology; it's an actual charity. And then we're going to be talking about the situation that led to the actual rewrite itself. And Rob's also going to be talking a bit about the plan and the result. So if you just yeah, next slide. Yeah, so dress code is basically a charity that was set up by Tony Scullion, a computer science teacher, and the purpose behind setting up the dress code of the charity was really to try and bridge the gap in computer science and knowledge amongst girls, mainly of school age. There's a number of ways in which the charity tries to do that. It's not just the actual lesson starter tool, which is what we're talking about. They try to do that by bridging the gap through things like competitions at schools, lectures from inspiring computer science females, and there's also things like competitions. I've mentioned that, and general news and articles, but in particular, and this is what obviously the talk is about, there's the lesson starter tool, and this has been developed for dress code by the STA. And in a nutshell, what it really does is provide a platform for teachers and content creators to upload lesson starter tools for the students, and it takes the form of roughly 250 preloaded lesson starters with the application, and that comes with interactive coding questions, a diary feature, and things like videos. So I'm just going to pass back to Rob for the next bit on the situation.
All right, cool. Yeah. So, yeah, like David said, I'm going to talk about what brought us to rewriting the entire thing and a little bit about what we plan to do, and then David's going to take you through the actual implementation and some of the bits that we used.
Yeah.
So, basically, the project started out with a particular philosophy for development, which was basically to have a really low barrier to entry for people coming into the project. So there isn't a lot of library code. There's a lot of low-level code. Everything is sort of built in-house, and that I think probably made a lot of sense at the beginning, because on paper it is actually a fairly simple project. Like it's just an API, a little bit of data storage in the back end, not a huge amount of business logic or anything. So it's a perfectly like reasonable thing to do. The problem is that things got more complex, and also the original developers left, or the main developer particularly left the project. So not that many people were left with knowledge on the like pretty large amount of very low level code that probably could have been done by a library instead. But this isn't to like shame the original development or anything, right? Like if you do it first, you get to do it worst, right? Like it's always easier to write version 2. And it's also much easier to look back and see like, oh, that didn't work, rather than look forward and know if something's going to work or not. So like, yeah, basically just because of the organic growth and how things got more complicated, there's just a lot of code that not a lot of people understand. Adding to that is that the project originally had a lot of time pressure on it. There wasn't a lot of time to deliver it. So things like test coverage, using TypeScript over JavaScript and things like that just weren't really, I don't know if they were considered or not, but we didn't end up doing them. There's also no sort of documentation on the API schema. In fact, there is no API schema. You just have to know sort of what the values are that you have to give the API. So those things all add up to difficult maintenance, right? Like there's a lot of code, it's not very well understood, a lot of time pressure to sort of cut corners here and there. Because of that, the confidence in changes became really low. It's just very hard to know if there's no types, no tests. If I'm changing something, is that actually going to break something? There's also a bit of a lack of abstraction, like changing something in the backend, even though it seems sort of internal, can actually break the front end. A couple of other like technical things like that just basically made it difficult to maintain the site. That also sort of resulted in very large deployments. In fact, there was really only one deployment for the project originally, and then we're working on version 2, which never got deployed, and it would have been a gigantic deployment. And because the project doesn't have any support for database migrations, so changing the database schema to add new fields and things like that, it's basically impossible to know if the code that is in development is actually going to work in production. It would be like a very tricky operation of getting the production database, checking if the new code works, changing bugs and things, and then only deploying when you're sure that everything works. So it's just a bit of dicey thing, right? To see that sort of in graph form, I made this little diagram that I think shows fairly generally how something like this can happen. I've had projects like this before where you have a lot of time pressure, and so you make some decisions that look like they're going to make things easier. So, you don't invest in things that aren't strictly necessary for the project, like typing, like tests, and you avoid sort of big frameworks, big upfront architectural thinking. You just start building it, right? And that's kind of nice because people get on board quickly and you get very rapid early progress, right? Like if you're writing everything yourself, you don't have to make any compromise. You don't have to do a lot of learning or anything. And you just get some things done very fast. You can even get to a first version very fast. But the problem is you end up with a lot of code. That code needs a lot of maintenance. Because there's a lot of time pressure, there's no time to ever refactor that code and sort of improve it, keep it maintainable over time. So your code quality gets worse, which means you need more maintenance, which you can't do because you don't have time for it. So the progress just slows down. And then there's this separate thing here where if you don't have types and tests, you cannot trust what you're doing. So again, your progress slows down because you have to double and triple check everything. So that's basically where we ended up. A little bit of a tricky situation where we basically just got pretty much stuck. So what we decided to do is to basically just rewrite the backend, which is not surprising as that's what the title of the talk is. The idea was we're going to rewrite, but as little code as possible. We're going to do the exact opposite of what we did before, and just everything that there is a good supported stable library for, we're going to use that library. So Django, which David is going to talk about more in a bit, is a big, old, boring Python sort of web framework that does everything. It's very old. Again, there's going to be more details about it later, which means it's very stable and has a lot of support for stuff. So we basically have this 4-step process of what are we going to do? How are we going to get to a working platform again? So the first is to use an ORM, which is an object relational mapper. It's a bit of a technical thing, but it just basically means you get a lot of support in interacting with the database. So we're getting support for migrations built in. So when someone makes a change in a pull request that means a new field or a new constraint or something else, Django will let us know if that's unsafe. Like if you're adding a field that cannot be empty and you're adding it to an existing database, Django goes, hey, what are you doing? I don't know what value to put in the existing rows for that. Your website's going to break, right? It also has a lot of validation and support for typing. So you know that you're asking the right things from the database, you know that you're putting the right things in the database. If you're doing something invalid, then it blows up, which is great. And there's no handwritten SQL. That one is a little bit contentious. Some people like writing manual SQL, and there's nothing necessarily wrong with it. But you do have to be very careful with it, not to put in security like issues like SQL injection vulnerabilities and things like that. So it's kind of nice to just be able to write Python, and this big framework takes care of a lot of stuff under the hood. It also comes with an off-the-shelf admin. It's not the prettiest thing in the world. I think David will show it, but it's super powerful. It lets you do a lot of stuff. So that for us was already like 1,000 lines of code related to managing the app deleted. Then once we have that, so we have an admin where we can manage data and we have a nice database layer. Now we restore the API endpoints that we actually need. There's a lot more abstraction and simplification in here now, which again is very easy to do in a second version because we already know exactly what the front end needs. When you're writing it originally, you don't necessarily know like what changes are you going to have to make. You might over design some things. So we could simplify a lot. And because of all the fun libraries that we're using, we're getting built-in documentation. Again, something David's going to show later. There's just out of the box a bunch of cool documentation stuff that we don't have to do ourselves. And then lastly, once we have a backend again, which now is not compatible with the old front end, we need to update the front end to make fewer, better API requests and delete any of the admin stuff that was there beforehand, which now we don't need anymore. So that's the plan. Sounds great on paper. Some people who've done this sort of thing before might now go like, hold on, why are you doing that? Like everyone knows that this is a bad idea. Like you should not do this. Like 99% of the time, don't rewrite the stuff. I have some links here, which I don't know if we're going to share the slides afterwards, but there's a lot of articles online, a lot of famous examples, Mozilla being one of the big ones where they completely decided to like rewrite the browser and it was a gigantic catastrophe. It's so easy to underestimate how much work it takes to rewrite something, and it's almost always easier to just not do it, right? What you should be doing instead is refactoring the code carefully, gradually, just making things better, add a new library here and there where it makes sense, add a framework when you can. Actually, like understand the code base because there's always the impulse of, I don't understand this, I'm going to throw it away. It's way faster usually to just dive into it and just understand it and slowly add typing as well. Like in Python particularly, but also in JavaScript, adding TypeScript is usually not that hard. And that already makes it much easier to refactor an app because you know when you're making terrible mistakes. So the question is, if all of that is the case, why did we do this, right? And basically, we tried not to at first, right? Like we tried to add TypeScript and we just couldn't do it. It's partially because the code is quite messy, partially because we didn't have that much experience with the code base. I think there were two separate attempts of adding TypeScript, and we probably could have done it, but each of them were just massive PRs where we didn't really know if we could actually release the code afterwards, because again, it's very hard to refactor something when you don't have tests, right? So this was a little bit of like a chicken and egg problem where it's hard to add typing when you don't have typing because you don't know if in the refactor you've actually messed up some things. There's also a part here where the app actually uses types sort of incorrectly. So if you add TypeScript, a lot of stuff breaks and you have to change functional bits, which is difficult to do because now it's not just a pure refactor, you're changing functionality. We did a refactor of the auth system, which already deleted like 1,000 lines of code. And that did help. It started making the code a little bit better, but it was just not enough. We were still getting stuck. Every time we tried to change a little thing, we would get bugs because if we change something in the database, it actually changes what comes out of the API because there were some missing bits of abstraction in there. Again, that just made things difficult to change. Also, none of us had experience with any like node-based ORMs or any high-level frameworks because like obviously we changed programming language in the backend here. We went from Node to Python, which is an extra bad thing to do really, but we just didn't have anyone in the team with experience of the tools that I'm sure exist in the Node world. But basically we were just stuck. We tried all those things, but we just found ourselves not even be able to fix bugs and much less having the confidence that we could actually release the new version without breaking anything. So on the other hand, Django is pretty low risk. Like we understand the app, we know what it has to do. It's pretty much just a CRUD backend. This just means like, you know, it's a basic standard API where you create objects, you read objects, nothing more. There's pretty little business logic. So it's actually a fairly low risk sort of situation. And I happen to have a lot of experience with Django. I've done this sort of thing several times. I've used it for like 15 years. So I was confident that we wouldn't hit any big roadblocks where it was like, well, we can't do this with Django. Like we knew that it was going to work, basically. Also, we didn't need any backwards compatibility. It was fine for us to break the API and just fix the front end. So that makes things a lot easier. And also the biggest luxury, we didn't really have much time pressure now, right? We could take our time with this. if it completely failed, we could have just thrown it all away, but it worked. So yeah, here we are. So yeah, that was basically where we started and what we plan to do. So David's going to take back over now. I'm going to stop sharing my screen, and we're going to talk about Django, which I've mentioned a lot, but not actually explain what it is.
Yes, thank you. Okay. Right. So is that everyone see that?
All good.
Yep, great.
Yeah, yeah, thanks very much for that, Rob. And as Rob said, I'm just going to give a quick overview of what Django basically is. So yeah, Django, in a nutshell, Django is a web framework written in Python that's designed to make it easier, faster to build web applications. And it's Django's philosophy is the web framework for perfectionists and deadlines. So basically, it prioritizes things like rapid development, code readability, and it does that through a number of ways. But amongst its philosophy is things like, don't repeat yourself, loose coupling, and code maintainability. In terms of what Django actually comes with, it's basically provides object relational mapping. So as I'll show you in a minute, all the actual SQL is abstracted away in the form of basically helper functions, which simplify the process of developing. One of the attractions of Django as well is the fact that it comes with an admin panel or an admin interface, and although it's not terribly attractive, it is very powerful. And basically, one of the attractions of the admin interface is that allows you to manage things like content, manage users, as well as authentication. In terms of the more sort of technical specifics of Django, in contrast to something like Ruby on Rails, which uses the well-known model view controller design pattern, with Django, it uses something called MVT, the model view template pattern. And basically what that is a type of design pattern where the data models, that the model handles the data structure, the databases, the view handles things like the user requests and underlining business logic, whilst the template itself is the presentation layer, which is responsible for what the user actually sees. Typically in Django, this would be rendered in HTML, but as we are doing with this, with dressCode, it's rendered in JSX in the form of React. So you can use Django with, pretty much any front end. Django is also very scalable. It puts a bit of emphasis on security. You can also use Django with pretty much any database. So I think we're using MySQL, but you could also use it with anything like Postgres or SQLite, and it makes the database management a lot easier. So that brings me on to the next slide. Django Ninja. So throughout this project, we decided to use a tool called Django Ninja, and what Django Ninja is basically a modern web framework for building APIs in Django. So it sits on top of Django as an abstraction, and it basically utilizes a library called Pedantic for data validation. And I mean, Ninja basically simplifies the process of writing what would otherwise be more verbose code in Django, and it comes with a number of helper functions. One of the biggest attractions, and is why we used Django Ninja, is the fact that it auto-generates the API documentation using Swagger on the fly. So I mean, basically what that does is it can, save the developer a lot of time having to otherwise write a lot of additional documentation, for example, typing it all up, as was the case before in Notion. And yeah, Django Ninja basically uses type hints to automatically generate the endpoints. And it's, one of the attractions is it's also very performant. So I'm just going to move on to the next slide. So I'm not going to go through this line by line, but basically these two code snippets are just giving you a kind of flavor of what the code looks like using Django Ninja. This line that's highlighted, basically what that's doing is it's using Django's query set to fetch a teacher model with a matching email for that particular logged in teacher. The abstraction below, the snippet below, test login bad email, the purpose of that was just to show you how we're using a library called PyTest for all the unit tests. And that's it. It makes it a lot more easy to do thorough testing of Django. So yeah, as I mentioned, all the SQL is abstracted away. So on that highlighted function above with the teacher, the filter function here under the hood, that's actual raw SQL. So what did we learn from using Python? So one of the reasons, although obviously not the main reason we chose to go with Python, was because it had the added attraction of basically allowing several people on the project to learn either Python or Django or both, depending on their experience. In my case, I didn't have much Python experience, and I certainly didn't have any Django experience before starting this project. So, when it was suggested we use Django on this project, although I was a little bit hesitant at first, it's actually been a great benefit to learn Python and Django. And yeah, it's expanded my knowledge, and I think all the other volunteers would testify to exactly the same thing in terms of how we went about incorporating Django, given we didn't have any knowledge. Well, Rob provided a number of helpful web links, which are actually at the end of this at the end of the slides, if we share them. So we did a bit of upskilling first of all, and we also started by breaking down tickets to let one individual tackle a specific problem. I think we called them warm-up tickets to begin with, before moving on to more advanced tickets for features. And in general, in terms of good practices, what we've done in contrast to the original backend is we've used a lot of unit testing and very widespread test coverage. In fact, we've actually had 100% test coverage for the backend, which, although some might say excessive, has also meant that we avoid some of the pitfalls of the previous backend in avoiding, edge cases going unknown and bugs creeping into the system. And the unit testing has been carried out in PyTest. In terms of use of libraries as and when required, basically what we did, and as Rob touched on, we've used libraries and dependencies as and when we need them, but we've avoided having too many dependencies so we don't end up with an unnecessary amount creeping into the actual code base. Pull request reviews, well, yes, everything's been reviewed via pull requests for different features and bugs that we've individually fixed. And yes, that's some of the practices we've been using. I'm just going to now give you a very quick overview of the admin panel dashboard for Django and also the API documentation. So let me know if you can't see this, but hopefully I take it you can see this in front of you.
Yep, all good.
Yeah, so this is what the admin Django administrative panel looks like. So it's not the most attractive looking thing. It's a little bit dated, although you can actually customize it. But as you can see, it provides ways to customize authentication and authorization through groups. And underneath the bit that's titled core, if I go into, for example, lesson starters, it's got two lesson starters, image starter and video starter. And I don't know if you can actually see the button, but if I wanted to, I could actually, using the dashboard, add additional lesson starter to this. The same goes to teachers. If I wanted to, I could add an extra teacher and manage their permissions from this dashboard. So, in summary, it's very, very powerful. It provides a number of ways to customize content, authentication, and permissions. And of course, we've actually done away with having the administration in the front end precisely because of this. I'm just going to turn now to the documentations. And as you can see, this has all the endpoints which are documented and annotated in the actual code base. I'm not going to go through all of them, but as you can see, they're sort of split into sections. For example, authentication, diary, course, and lesson starter. So if just going to move this out of the way, if I click on, for example, lesson starter, because actually, yeah, I'm going to have to type in everything in that. Okay, if I click on less courses here, there's a button you can see, try it out. So if I click on that, execute that, and it brings up currently the two main courses that I just called generically course 1 and 2. And so it allows you basically to try out and test all your endpoints in the server, which is obviously very helpful. It's also useful for non-developers for documentation purposes. To give you another example, because I'm currently logged into the dashboard, if I click on teacher and the current teacher under me, execute that, and as you can see here, you get a response just telling you you're logged in as admin and the admin email address. So yeah, in summary, one of the benefits of using Django Ninja is that it can basically make use of Open API to introduce you to Swagger sort of style endpoints, which make testing very, very easy and powerful, and good for documentation. I believe that that's the end of what I'm talking about, and I'm just going to now pass you back to Rob to carry on with the rest of the presentation. So let me just stop sharing. Thank you.
Thanks. All right. Right. So basically, where do we end up with all this, right? So as David showed, we now have this nice admin panel. We didn't really show the front end. It looks the same as before, and it doesn't 100% work yet, though it does, like 95% work, like to the point where we're back at the starting to test and just fixing a few bugs and things. But basically, this is where we ended up. So before, we had a lot of low-level code. We had to manage our own auth and permission code, manage the database ourselves. You can't see my screen, right? Yeah. Just to check.
Yeah, thank you.
Right. And our own code for transforming data, which is not something we talked about, that how data gets serialized and deserialized between the front end making a request, it getting turned into Python, turning it into the database, retrieving things from the database, putting them back into JSON, sending them to the front end. There's actually a lot of complexity there, which previously was all manually written. Now that's just part of the libraries, these Pydantic and Django Ninja libraries that David talked about. We about halved the code. So it was before 10,000, now it's about 5,000 lines of code. Those 5,000 lines actually include the tests, of which there's a lot more now. So in terms of functional code, it's even less than that. And the business logic itself is actually very little. Most of this is just defining what the data looks like, which is always a little bit of boilerplate that is required. So yeah, as mentioned, now everything is fully typed, fully tested. So everyone who joins the project, if you make a silly mistake while editing the code, even your editor just helpfully points it out and goes like, oh, that's the wrong thing. You meant to use this thing. So it's just a lot of like quality of life improvements for development as well. The API previously was very verbose. I didn't go into detail, but there were a lot of, so you have to make 3 API requests where now you only have to do one. Each request for like lesson starters now includes things like the favorites and the tags and everything else that previously had to be fetched separately. So it's just a lot easier to use on the front end. Obviously, all the like built-in docs and things are nice, and we have the like built-in admin functionality. So yeah, that's basically where we ended up. It all worked pretty smoothly. Like David and Craig, who started learning Python, and Jamie as well, who's mostly working on the front end, but like got involved on back end things here as well. Like very quickly picked it up. And like Django is not a super easy thing to learn. Like it is obviously large, and we're putting libraries on top of it, but yeah, everyone did a very good job like getting up to speed with things. So yeah, that's where we ended up. One little side note on the API changes is like obviously we didn't just purely refactor the backend because we wanted to improve the API. So the abstractions are now much better, and the core thing I wanted to mention here is just that the front end code is also much smaller now. Like because we could throw away the admin, we can make fewer requests. There's just less stuff there. So even though this was mostly a backend refactor, the people on the team working on the front end have actually also deleted a lot of code, simplified a lot of code, and already removed a bunch of bugs, and just makes it much easier to iterate on that side of things as well. So yeah, that's where we ended up. There's a couple of links here. I'm going to try to share this so I can still answer some questions in the meantime. So yeah, I think we'll share this around, or at least we'll share the links around. So there's bits on dressCode in general. There's actually a link to the live docs of the dressCode API. This is our dev site that we have running right now. So this might change, it might break sometimes because it is just a dev site, but you can check out those auto-generated docs there. Some links on Django and Django Ninja, and like general tutorials. And then, of course, before there were some links to articles explaining why usually you shouldn't do this. So yeah, there were a couple of questions in the chat. I'll just get back to that. Second. Right. So there was a question. How long did it take the team to develop a full understanding of the existing code base before deciding on a rewrite? Were there any significant challenges in reaching this understanding? So I was on the project for about 6 months, I want to say, before we started this. I think David, you were there for like a year or so.
Yeah. I mean, yeah, I think it's almost a year I've been doing this actually, and so this time last year when I first started with the code base, at that particular time it was all the old code base with Node.js and just React on the front end, but it was very, very complicated. Even just getting the actual project set up was complicated and not easy. But it probably took, I don't know, 3 or 4 weeks to completely familiarize myself with the code base. But definitely one of the challenges, and I think Rob would be the same, is that it was just because of the way it was written. It was just quite hard to reason with a lot of the underlying code, both for the front end and the back end. And on top of that, there was a lack of documentation explaining it all.
Yeah, I would say I spent the first 4 months trying to avoid the rewrite, and then we spent the last 2 months or so, maybe it's more now, I don't quite remember, doing the actual rewrite. Were there any existing functional requirements or helpful documentation that facilitated the team's understanding of the project? If so, how effective were these resources in providing clarity? So there was a lot of sort of developer-facing and general project documentation. People actually did a really good job on like explaining the project on Notion, where it came from, how it was designed for, and like bits on the architecture as well. So what I was saying before about low barrier to entry and things, all those things were actually explicitly laid out in the docs. So documentation on the project was actually very good, and like understanding the project and the goals of the project is pretty easy. And like I think those parts of the project were great. Just the actual code, usually handwritten documentation like that doesn't help that much in understanding the code because it goes out of date. The code changes, and also there's just a lot of code that like it's difficult to explain every line. There was documentation in the code base, of course, as well. So like we definitely did try to like understand things pretty thoroughly, and we did, do a release where we fixed some things before we attempted the rewrite. So yeah, like that, those docs were pretty useful, I would say, uh, for the aim, but not so much for the implementation. I'm just going to see if they no. Okay. And then the last one was, do you think having engineers with more experience in Node.js could have influenced the decision to pursue a rewrite, or would the project challenges have ultimately required it regardless? So I would say that the backend always needed a rewrite, but if we had someone with Node.js experience, I'm pretty sure we would have just picked a Node.js or framework. I am convinced that there are some good ones. Like there's a lot of stuff out there, but it's very hard to pick something that you've never used where you don't know the wrinkles, and you don't have anyone on the team who has a lot of experience with it. That's why this seemed less scary, even though we were changing languages. But yeah, I don't think we would have moved away from Node.js if we had someone.
Yeah, we did consider a few options, but it was the lack of thorough understanding of those that meant we decided to switch away from Node.js on the back end.
Yep. Yeah, that's us. Does anyone else have any questions? Yeah, Jean? Oh, you're muted.
Mute myself. If it had been done this way in the beginning, how much longer would it have taken?
That's a really good question because, yeah, like I sort of implied that, the cause of the whole situation was the time pressure and then like the decision made because of the time pressure. It's hard to know in retrospect, right? Like, I think it probably wouldn't have taken more time, actually. I think if you have someone who's experienced and knows sort of the setup and the wrinkles of a library like that, even though there is a little bit of like initial work, I don't think it actually takes that much more time. So on the rewrite, I think it took about a week to set up sort of the framework in general. So like that there's maybe a week of extra work, but then everything after that becomes a lot easier. So like it's very easy to do a project where you already know what needs to happen, right? Like if the requirements are super clear and everyone knows the technology involved, software engineering can just be engineering, right? And like it's just, yeah, we know what needs to be done, we know all the parts, bam, 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 just put them together, it's fine. But usually projects just don't go like that, right? Like I assume, even though I wasn't here at the time, that we just thought it was going to be much simpler, right? Like there's that famous saying, we don't do it because it's easy, but because we thought it was going to be easy. And like that's always how it goes, right? So could very well be that if I had been there at the start, we maybe would have used Django, but still maybe we wouldn't have used Django Ninja. Maybe we would have like used a different database that maybe wouldn't have been optimal. There's a bunch of things that can go wrong if you don't quite know what the challenges are going to be yet, right? But I do think that starting with like a very low level approach and not using sort of existing code is probably usually not the best idea. It does depend. Like part of this project obviously is also teaching people, and for that sometimes it's very nice to like build everything from scratch. So from that perspective, it can be useful. But when it comes to web stuff where there are libraries that have existed for 10, 15 years that are just tested to within an inch of their lives, I would just go with those, even though it takes a little bit of time to get started with.
So as you know, I'm not technical at all. I'm a business analyst and sometimes tester who joined the dressCode project in order to test the first release. I'm wondering, I have read in various things within SPA that React is preferred for front end. Know no more about it. For the back end, should STA have some standards which we try to adhere to and get people to use? And might this be one? And are there circumstances when this setup is the right answer? Sorry, this is a whole bunch of questions, but where this is the right answer, but it wouldn't always be. How can we best use your learning for future projects is what I'm trying to get to.
It depends on the team. I mean, I'd say it depends partly on like I'd say it would be very helpful to have some sort of standards and to adhere to. But I think at the same time, because it is a volunteer project, you also need to take into account, you know, obviously the client who you're building it for. In this case, it's been dressCode, but also just the volunteers themselves. I mean, what are they going to get out of it from a learning point of view? But yeah, I don't know what Bob would think.
So I would say that like this is a good tool, right? Like obviously I'm biased. I've mostly used Django for most of my career. I've used other frameworks, but this is the one that I usually come back to. So I think it's a very good tool for a certain kind of problem, but it is just a tool, right? Like I know that we use WordPress a lot for sort of more standard websites, and like I think that's a perfectly good tool to have in the toolkit. I think also sometimes something more low level can be good when you know that it's going to be something very, very small. So I'm not sure if a single standard is something that I would aim for, but I think what we are missing, or at least I haven't seen it a lot, is the ability to use solutions that other projects have already done, right? Like I don't know if there's any framework for me to look at other projects and steal some of the code that they've started with. Which, from my own perspective, whenever I start a project, I start by stripping any parts I can from the last project, right? Like that's always how I start. And like to me, that would be very useful, right? Like having the tools to just yeah, look at a project that's already very similar, that works quite well, where we maybe know some things that are good or not good about it, then taking the good bits, changing the bad bits, and going from there. Because usually every project is different, and also, next year there's going to be another cool library that maybe makes some other things easier in this. So I wouldn't want to sort of petrify like a project and just always use the same tools there, right? But I do think Django is a very good foundation, and if any other projects want to like investigate using it, I'm always like up for like showing people how it works.
Thanks, Rob. And I see there's a comment online too that there's tons of tools out there. Yes.
Yeah, there is. And
my lean background is always to be choosing standards.
And as they say, the best camera is the one you have with you, right? It's the same with technologies. I think like if you have something that people know, then that's going to be fine, right? Like you can make use of whatever technology as long as people know it well enough to not get themselves into trouble. Yeah, and that is a challenge, right? Like I might leave, and then like there's no one on the team who's very experienced with Django. The idea here was to keep it pretty simple and keep it standard so that you don't have to ask me. You can just look online and like Google a problem. But yeah.
Cool. Thanks.
Well, if that is all, I just again want to reiterate, thanks so much, both of you. The presentation was so interesting, and yeah, I feel like we've kind of left on a cliffhanger of what can we do with other projects. Oh, not sure, but anyway, that was such a useful, insightful discussion. So thank you so much for giving up your time.
Thanks.